Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve an inverse trigonometry function problem. As per the problem, the number of integer x values for which y is positive in the equation tan inverse x plus cotangent inverse y equals tan inverse 3 is. We are given 4 answer choices. We have to choose the correct answer choice. In this problem, we have to find the number of integer values for x for which y is positive. We should use the given equation to isolate y on one side of the equation. The given equation is tan inverse x plus cotangent inverse y equals tan inverse 3. We should gather the tan inverse terms on the right side of the equation. We should move tan inverse x to the right side of the equation. It will become minus tan inverse x. Next, we can use the tan inverse identity for subtraction of two tan inverse terms. We can combine the two tan inverse terms into a single tan inverse term. As per the identity, I get tan inverse 3 minus x over 1 plus 3 times x. We can simplify the term on the right side. Three times x is equal to 3x. In this equation, we have cotangent inverse term on the left side and tan inverse term on the right side. We can change tan inverse to cotangent inverse because that way we will be able to get rid of the inverse functions. We can write tan inverse 3 minus x over 1 plus 3x as cotangent inverse 1 plus 3x over 3 minus x. We flip the fraction to change tan inverse to cotangent inverse. Now we have cotangent inverse on both sides of the equation. We can cancel it out and we are left with y equals 1 plus 3x over 3 minus x. We have to use this equation to find the number of integer x values for which y is positive. As per this step, y is equal to 1 plus 3x over 3 minus x. Y will be positive if both numerator and denominator expressions have a positive value or both numerator and denominator expressions have a negative value. So we have to analyze both cases. Let's start with the first case. 1 plus 3x is greater than 0 and 3 minus x is greater than 0. We have to solve these two inequalities. Let's start with the first one. We can move 1 to the right side of the inequality. It will become negative 1. 3x is greater than negative 1. Next, we can divide both sides by 3. I get x is greater than negative 1 over 3. Now we can solve the second inequality. We should move 3 to the right side of the inequality. It will become negative 3. Next, we should change negative x to positive x by dividing both sides by negative 1. As per the rule of inequality, we should flip the inequality sign. I get x is less than positive 3. So we have to find integer x values that are greater than negative 1 over 3 and less than 3. The integer x values are 0, 1 and 2. So as per case 1, there are 3 integer x values possible. Now we can analyze the second case. The second case is that both the numerator and denominator expression have negative value. So the first inequality is 1 plus 3x is less than 0 and 3 minus x is less than 0. We can solve these two inequalities. Let's start with the first one. We can move 1 to the right side of the inequality. I get 3x is less than negative 1. Next, we can divide both sides by 3. I get x is less than negative 1 over 3. Now we can solve the second one. We can move 3 to the right side. I get negative x is less than negative 3. Next, we can divide both sides by negative 1. We flip the inequality sign. I get x is greater than 3. There are no x values that are less than negative 1 over 3 and greater than 3. That means for no x value will the numerator and denominator be negative. So from case 2, we get no solution. That means in the given equation, y is positive for integer x values 0, 1, and 2. So there are three integer x values. That means the answer should be option D, because we have to find the number of integer x values for which y is positive in the given equation. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.